Okay, so let's start the session. So in the last class, we have just completed the descriptive statistics part. And in today's class, we are going to discuss the next topic called as matplotlib. Okay. So if you remember in the last class, we have seen the types of variables, different types of variables, right? In that variables, we have worked on the variables called as continuous variables and discrete variables, and along with the time series. So three different types of variables will be there. And just we have done in the previous class measuring. Now in this, what we are going to do is we are going to plot the data. We are going to do the plotting. Plotting means nothing but graphs. How we are going to take an empty graph sheet and how we are going to draw the bars, or how we are going to draw a line like this, something. How we are going to take an empty bar sheet, empty graph sheet, and how we are going to draw. Similar way we are going to do this one. For this, we are going to use some kind of plotting library. For this, we are going to use the plotting library, which is called as matplotlib. Matplotlib, mathematical plotting library. The full form of that is mathematical plotting library. Okay. Now here we are going to use this one, and we are going to plot the various graphs using matplotlib and also using the Seaborn. Seaborn is with respect to advanced. This is the basic one. This is the advanced one. Before learning the advanced one, first we have to learn the basic one. Directly we can't enter into the advanced one. So that is the reason first we'll start the basics and then we'll learn the advanced things. Now here, the most important thing is we are going to do the univariate, bivariate, and multivariate. What is meant by univariate means you are considering only one variable and you are going to make a plot on the single variable. Single variable means by considering a single column. By considering only single column, if you plot anything, then it is called as univariate plots. If you are using two columns and you are making a plot, using the two column values, you are making a plot means, then it comes under bivariate. Using two columns, using two variables, if you make any plot means, then it is called as bivariate plots. If you are using only one variable and if you are making a plot means, then it is called as univariate plot. And if you are using multiple variables and then only you are able to plot that one, then it is called as multivariate plot. If you are using more than two variables and you are making a plot means, then it is called as multivariate plot. Right? Now, here we are going to see with respect to univariate plots, bivariate plots, and multivariate plots. And for both continuous, for discrete, and for time series, everything. Okay, one by one. And this is one of the most important. Right? Now, the basics, whatever we are going to start is matplotlib library, which is available in the Python, which is extension of NumPy, where we are able to do with respect to the plots. The advantages of matplotlib is very easy. It is easy. Comparatively with any other plots, this is the easiest one, and where we can write the custom labels and text. Now, what is meant by custom labels? Custom labels means you are designing your own label. What is meant by label means the name of the y-axis or name on the x-axis. You are going to write the name now. That name you can write as per your choice. The naming you can keep. The name is called as labels, right? And we are having a great control on each and every element in a figure. And we are going to get a high quality in many formats and which is customizable in general. So let us see with respect to one by one. First, import NumPy as NP, pandas as PD. These are the two libraries. Now we are going to start the third library called as matplotlib.pyplot. Matplotlib.pyplot as PLT. I am going to use the as PLT. Now, percentage matplotlib space inline. What is the meaning of this means? Whatever you are getting the graphs, every graph should be inside this one only. Inline of this one means inside this. Nothing should be crossing this one. That is the meaning of inline. And this is applicable only for the previous versions. Now you are working on the latest version. Whatever. If you have installed your Anaconda latest, for the latest version, you don't need to write this matplotlib inline also. For the previous versions, we have to write this one. For the latest versions, we no need to write. Now here I'm going to create a data frame called as study hours and grade. So I'm having a data set like this where 20 values, something like this, 20 values I'm going to take. Now I'm having two columns called as study hours and one more column called as grade, where I'm having the some values. Two columns are there. Now, if I take this info, total 22 records are there with values 22 records and two columns. You are having two columns. Now, univariate analysis means analyzing a single variable at a time. Bivariate analysis means analyzing two variables by considering two variables at a time. Multivariate analysis means analyzing. Plot means, univariate plot means plotting using a single variable. Bivariate plot means plotting considering two variables. Multivariate plot means by considering multiple variables. The plot, whatever the plot is there. Analysis means analyzing. Now, the first one is histogram. Histogram is used for the continuous variables. For continuous variables, we are going to draw the histogram. In histograms, the x-axis consists of the variable name and the y-axis consists of the frequency of that particular variable. So here I'm going to use plt.hist and I'm going to write for which column I want to give that particular column. How to access a single column? df of, for example, grade. For the grade I'm going to select means first I have to extract this particular column, and for this column I am going to apply the hist is the function. Is that clear? So it is, I'm going to apply the plt.hist. Hist means histogram. Just for example, let me remove all these things. Okay, let me remove all these things completely. Even this one also, let me remove. I'm having only plt.histogram of that particular variable. First, I'm removing even this one also. Okay, plt, that is df of grade. Df of grade means this particular column you have selected, and for this column you are applying the plt.histogram. Plt.histogram. So once you apply the plt.histogram, you are going to get a histogram like this. Okay, so the histogram you are going to get like this. And if on the x-axis, what column you have selected, for which column you have drawn the histogram, you can't see that one on the x-axis now. So for that, what I'm going to do is I'm going to add the x label. X label. X label means on the x-axis you are going to get the word called as grade. So see here, now you are going to get the word called as grade. X label, I have kept the word called as grade means the same grade will be printed on the x-axis. Y label, I am going to write as count by frequency. So you can see the label, the name, whatever the name I have given here, the name will be displayed as this. Next, plt.title. Title means histogram of the grade means this is the histogram for the grade column. And by default, you are going to have the number of bins is equal to 10. Sir, starting value, how it is selecting this one? First number it is this one, second number, how it is selecting? The numbers, how it is selecting, and from where it is starting means the number of bins. The number of bins by default it is equal to 10. So in this, the number of default bins is equal to 10. So if you open this one, here the bins, whatever we are having, the bins is equal to number of bins is equal to 10. So I'm writing bins bins is equal to 10. This is by default. So you want to increase the number of bins, you can write with respect to bins is equal to 15. Now each bar will be there, right? This is called as bin size. Each bar, the bin height is with respect to frequency, that I can't change. The bar bin, this one is there, right? This is called as bin size. How this bin size will be dependent, you know? Bin size is equal to maximum minus minimum value in the data set divided by number of bins is the bin size. For example, let us take like this. 1 to 100. I am taking the points from 1 to 100. Everyone knows, right? 1 to 100 means simple example. 1, 2, 3, 4, 5 like this up to 100. 1 to 100. Now 1 to 100, the histogram it is going to take from 1 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Why it is collecting with respect to 10? How it is giving means the maximum value here it is 100. 100 minus minimum value of 0. assume 0 is there, divide by 10. So now each bin size is going to be 10. The bin size will be 10. So starting value will be 0, 0 to 10, 10 to 20, 20 to 30. Each bin will be like this. Height will be number of values. Height is number of values. In my given data, height is number of values. Is that clear? So that is histogram. Like this, you are going to get a histogram where the number of bins you are going to, if you don't write anything, means by default, you are going to get this one. Now here, what is the use of histogram? What is the use of histogram means to check whether the given data is normally distributed or not. To check for that, we are going to use the histogram. Now from this, you can tell me whether the given data is normally distributed or not. Just you are going to draw a curve like this, and if it is normally distributed, and you can see one point is an outlier also. Right? So histograms are used for checking whether the given data is skewed or normal. Right? The second one is called as box plot. So PLT dot box plot, and you are going to give as DF of grade. DF of grade means for this particular column, it is applying the PLT dot box plot. That is nothing but box plot it is applying, and you are going to get the box plot in this way. Where the box plot using the 5 numbers, and here you can see one dot is there. Means one outlier is available. Whether, for example, multiple dots are there or also here what is the use of box plot means to check whether the given data has outliers or not. That's it. How many number of outliers are there? What is the value of that outlier? Sir, this outlier, what is the number, sir? Whether it is 164 or 162, what is the number? This is all not important for us. And box plot is not going to give that value also. Box plot will give that advantage of box plot is whether the outliers are available or not. To check outliers are there or not. That is the only use. And in my case, if there are outliers are available, now how I am going to check the outliers are there? Okay, outliers are there. Now, which data point is an outlier point? How I am going to do it is that I am going to apply Q1 minus 1.5 into IQR. And any value less than to this, any value greater than Q3 plus 1.5 into IQR. Right? And how to get those records? You don't need to write the formulas. You don't need to calculate manually. For that, separate code is there that we are going to see in the further class, in the future class where we are having the data cleaning. In this exclusively outlier engineering will be there. Here, we are going to do purely for outliers, how to calculate the outliers. So how to check with respect to outliers and how to get that record, output of that record, which is outliers record, how to collect that record. And after that, what to be done, how to deal the outliers. This we are going to see in the further class. Exclusively, we are going to see in one session for outlier engineering. As of now, the box plot is used for checking whether there is an outliers are available or not. To identify in my data set outliers are there or not. That's it. Okay. If my given data, whether the given data is normal or skewed, to check only we are doing this one. If you want to convert from skewed to normal, if any data is skewed distribution, that skewed distribution has to be converted to normal. That we are going to see in the future transformations. Again, this is an advanced concepts. For doing that advanced concepts, first we are covering the basic parts. So here we are going to convert, if any right skewed distribution, we are going to convert to normal distribution. If it is left skewed also, we are going to convert to normal distribution. This we used to call as transformations. This is called as data wrangling techniques that we will be discussing in the later. As of now, once again, I am saying each plot, what is the use of each plot only we are seeing in today's class. How to make a plot and what is the use of plot. Only two things. One is what is the function for writing that plot. What is the code, function or code. What is the code for writing that particular plot. And after that, second one is what is the use of that plot. These are the two things which we are going to do today. After that, sir, you have observed here it is a skewed distribution, sir. What you are going to do? That we are going to see in the further. Okay. Sir, why it is further, sir? You can explain now itself now. If it is left skewed means how to convert. If it is right skewed means how to convert. You can explain now itself. Miss, what happens if I explain now, miss? In the further, when we are going to do the project, you will do simultaneously like that only. First thing in the project, we have to do the steps will be there, out of which first one is called as EDA. EDA means understand the raw data. Understand the raw data. Raw data means whatever the given data. Understanding the given data without doing any kind of cleaning or transformations or not doing anything, just observing the original data is called as EDA. After that, second step is called as data pre-processing. After doing the EDA, we have to do the data pre-processing, where we have to apply the data cleaning and data wrangling. Before this one, first we have to understand our data. In our data, how many continuous variables are there? How many discrete variables are there? Within that, how many of them are skewed? How many of them are normal? How many? Understanding the original data, raw data is called as EDA. So in the original project, we have to do in this way. So my training also I'm doing in the same way. If I combine both of them simultaneously, while you practice or while you do in the real-time project also, you'll do the simultaneously, which is a wrong one. First, you have to complete original given raw data separately. You have to do the analysis without cleaning that one. Analyzing the original data is called as EDA. This will be done by a data analyst. Data analyst role is this one only. For machine learning, we are doing the data pre-processing. Why we have to convert to normal? If you don't convert to normal, what happens? If you don't convert, what happens? Why we have to convert? Because all the machine learning algorithms are designed based on the assuming the data is normal. This is the assumption. Assumption of machine learning is assuming the data is normal. If the data is not normal and you have given a skewed distribution for the machine learning algorithm, the machine learning algorithm will give the wrong answers, means accuracy will be low. If you convert to normal distribution and then if you provide the data for the machine learning, means then the accuracy will be very high. Right? Sir, if you are not applying machine learning, then why you have to convert? If machine learning is not there, then no need of doing the conversion. Since we are doing the machine learning, we are applying the data on the machine learning, we are converting. Why we are treating the outliers? Why we have to delete the outliers or why we have to convert the outliers? Why? Miss machine learning algorithms will give the low accuracy. All this data pre-processing, why we are doing this? For machine to understand properly. If I give with a simple example, students will understand. If I don't give the simple examples, whatever is there in the PPT or whatever is there in the Jupyter notebook, if I read that one, what is the use? Getting the point? So here the same thing, just understanding the original raw data is called as EDA. That is entirely different stage. After that, applying the cleaning, why you are applying cleaning and why you are doing transformations? Because you are applying machine learning. If you don't apply machine learning, no need to clean the data, don't need to do the transformations. Nothing you no need to do. Right? Is that clear? So here just we are applying the histogram to check whether the given data is normal or not. We are applying the box plot to check whether the outliers are there or not. To check only. And next, scatter plot. Scatter plot is a bivariate plot. Scatter plot is a bivariate plot. Bivariate means two values you have to take. What is meant by scatter plot? Scatter plot means keeping a dots like this. This is called as scatter plot. How you can keep a data point on this one? For example, there is a data point called as 1, 2. This data point you want to place. Now, how you are going to place? On x-axis 1, on y-axis, wherever the value is equal to 2, you are going to make a point like this. For example, you are having 1, 2, 3, 4 like this. 1, 2, 3, 4 like this. Point of 1, 2 means this is 1, 2. If the point of 2.5, 3.5 is there, 2.5 is this one, 3.5 is this one, and you are going to keep a point like this. Keeping all these data points on the graph is called as scatter plot. Note, okay, for this we require two values. One is x value and one is y value. Without, for example, if I give you only one, if I ask you to plot only number 1, what is the y value? Without y value, how you can plot? Can you plot that point on the graph? So this plot you want to make means you require two values. Whether it is a positive or negative, that is secondary. If it is positive means positive, negative means negative. 4 quadrants will be having. But that value should be two values. One is x value, one is y value. Using x and y, you are going to make a point like this. And for all the data points, if you make like this, then it is called a scatter plot. So here, just observe this one. Here I am going to take the x is equal to df of study hours, y is equal to df of grade. Okay. Now I am going to apply the PLT dot scatter on x comma y. Now whenever I am applying the scatter of x comma y, what it is going to do? Just it is going to take this data points. X-axis study hours, y-axis is grade. So first point 10 comma 50. Wherever the 10 is there, wherever the 50 is there, this is the first data point. 11.5 comma 50. 11.5. Wherever the 11.5 is there, this is 11.5. This is the 50. Second data point. Third data point 9 comma 47. 9 and 47. Like this, it is going to make for each of the data point one point like this. It is just keeping one point on the graph. It is called a scatter plot. Just it is going to keep the points on the scatter plot. Right? Is that clear? Scatter plot is clear. So whatever you are writing in the PLT dot scatter, the function name is called as PLT dot scatter. This function is available within the PLT. Right? In the modules I have told you, import srk dot add. Now similarly, import the PLT. In the PLT dot scatter means just it is going to open the PLT dot py file. Within that scatter is the function is available. For that function, two input arguments are required. One is called as x argument and one is called as y argument. So whatever you are keeping on the x-axis, the values will be considered on the x-axis. Whatever you are keeping on the y-axis, it will be considered the y-axis values. So in the x-axis, you are considering study hours. So study hours will be considered on the x-axis. You have taken the y-axis with respect to grade. So grade values are taken on the y-axis. So here, whatever the x and y. So the grades you are having with respect to different values like this. These are the different grades and this is the with respect to study hours. So now using the two columns, you are able to make the plot. Using single value. For example, you are want only with x. You have given only the x. And if you are asking this one, it is going to throw an error. Because scatter requires two arguments. One positional argument is missing. You want to understand this one very clearly, miss functions. In the functions I have told you. Positional arguments, keyword arguments, compulsory arguments. This you have to give, otherwise it will not take. Do you remember? So here, this function will take with respect to the arguments of two arguments. It is not going to work on the single argument. Whereas this box plot will work only on the single argument. Here only one argument you are going to give. One variable only you are going to give. Whereas here you have to give the two arguments. Argument 1 and argument 2. So the first argument is x. Second argument is y. Sir, but I want to take the grade on the x-axis. So grade you want on the x-axis means first you select the df of grade. I am selecting the df of grade here, comma. Now df of study hours. Okay. Now whatever you have written in the first portion, it is automatically x. Whatever you have written in the second portion, it is x, y. It is in the positional arguments. They are positional arguments. So whatever you have written in the first one, so now x-axis will consist of grade values. Y-axis consists of study hours values. Now you are going to get like this. So y-axis you are having study hours, on x-axis you are having the grades. Now for this particular, whatever the example we are having, in this x comma y, along with that, we are having some others like color. Color of the point, whatever the color of the point you want to give, you can select the color. Color I am going to take as blue. By default, it is blue. If you don't give also, it is going to take the blue only. If you want to have the red color, you are keeping the red color data point. So you are going to get red data points. Point, whatever the point you are going to keep, that is red. And type of the marker means, for example, you are taking like this. Here, I want to make with respect to 1, 2, 3, 4, like this are there. 1, 2, 3, 4 is there. I want to mark the 1, 1. 1, 1, that too red color or pink color, which is star. I want to mark like this. Now, what you want? Pink color. So you are selecting the pink. If you want red color means you are selecting the red color. So now if you are selected the red color means it is going to take the red color, and you are keeping the star means it is going to select the star. If you keep the star means it is going to keep all the data points as the star. And the size of this one I'm giving as 30. S is size, marker size. Marker size. If you don't give the marker size, for example, marker size I'm giving as 3. Small. Marker size is nothing but whatever this one. If I want like this big marker size, if I keep with respect to 300, the size of the marker. Marker means whatever the marking you are going to make. So generally, we'll not focus on this one. What are the different types of colors? What are the different types of colors? What are the different types of markers? Don't ask that question. Here for me, that is not important. For me, with respect to, nothing is important. All of them are not important. Just I will write only the plt dot scatter of x comma y. By default, it is going to take the blue color and circles only. I will just keep the default values. I will not focus on the colors here. For me, coloring is not important. Now from the scatter plot, what you are going to understand is, as x values increases, y is increasing or decreasing. That you have to understand from the scatter plot. The relation between the direction, you are going to get the direction. Whatever you are having on the covariance is there, covariance is positive means both are directly proportional to each other. If the covariance is negative means both are inversely proportional to each other. The same thing you are going to get by using the scatter plot. From the scatter plot, you can clearly say that as the x value increases, y also increasing. If the scatter plot is like this, as x increases, y is decreasing. Right? From the scatter plot, we are going to identify the direction. That is the use of scatter plot. Here, the colors are not important for us. Okay? Here colors or marker size, these are not important for us. But still, if you are interested, means you can select these are the different things. Color along with the marker, along with the size of the marker. Okay. Next. So now here you are going to take by default it is going to take. And whatever you have written in the first portion, that will be considered in the first one. Whatever you have written in the second portion, that will be considered in the y-axis. First portion will be considered in the x-axis, second portion will be considered in the y-axis. So here, x I am writing clearly study hours, and x comma y means automatically x will be considered on the x-axis. What should be considered on the x-axis? Study hours. What should be considered on the y-axis? Grade. So now, if you want to save this figure, whatever the output you have got, this one you want to save means click on the save image as, and you can save wherever you want, on the desktop or wherever. Now, whatever you have saved on the desktop, if you double click on this, you are having this one. But here, there is no with X label is not there, Y label is not there. So if you want to add the labels, means you are going to add the labels like X label, plt.x label, plt.y label. Right? Now, here what is this plt.show? If you don't write plt.show, what happens means you are going to get one more line like this. This line is that I have worked the function. What is the exact meaning of this line? Don't ask, because I also don't know. Because it is not important for me. I never came across that one. Directly, these things are not important for us, means nothing, no need to show anything. Directly show only the plot, means directly you ask plt.show. Because if I know that one, what is the meaning of that line? What is the use for me? If I know means what is the use? If I don't know means what is the use? Then line is not important for me. So here in the plots, I require the plots, and by seeing the scatter plot, the direction is important for me. Based on the direction, I am going to move on to the next step. Is that clear? Next one is called as line plot. Line plot will be taken based on the, whenever you are having with respect to x-axis with time series. When you are having the x-axis on the time series. Now, for example, what is meant by line plot? Let me take an example here. Some x and y. Let us take 1, 2, 3. This is 4. This is 90. And this is, 9. Instead of 90, let us go with 9. And this is with respect to 12. Something you are having like this. Now, the same thing, first you represent on the scatter plot. First you draw the scatter plot. What is the scatter plot? 1, 4. This is 1, 4. 2, 9. This is 2, 9. 3, 12. This is 3, 12. This is the scatter plot. Now, what is meant by line plot means whatever the first data point is, that this is the first one, na? Which is the second one? This is the second one. So attach first and second one. From second to third one, you attach. This is called as line plot. In the sequential order, if you are attaching the data points, then it is called as line plot. Now, for example, since in my case, the x-axis is in the order, that is 1, 2, 3, in the order I'm having like this, fine. Now assume that in my case, it is not in the order. Okay, let us take one more example where 1, 4 and 2 is there. Now 1, 4, this is the first data point. 4, 9, this is the second data point. 2, 12, this is the third data point. First, it will go from here to here, from here to here. If the next number is, assume the next number is 3, 2. Assume 3, 2. 3, 2 means this one, 2 means this one. From here, it will come to here. Next number is 5, 10. From here, it will go to 5, 10. From there, it will come like this, like this, like this, zigzag way. Now, when if you go with the normal things, it is going to throw like this zigzag way. From this, we are not able to understand anything. So whenever you are applying the line plot, remember whenever you are applying the line plot, X should be in the sequential order. X-axis should be sequential data. If X-axis in the sequential data, then you can get a proper order. Then after this one, what happened like this, you can get a proper order. Then you can analyze. If the x-axis is not sequential, means you'll get the data like this. Now, what you will analyze from this? Getting the point? So here I am going to show you the example. See here, first x is equal to df of study hours, y is equal to grade, plt dot plot. For line plot, you have to use plt dot plot. Just a function called as plt dot plot. Now, if you plot like this, see, from the first data point to second data point, like this, it has added. Now, what you are observing here? You can't observe, you can't analyze anything. So, the x-axis should be in the sequential order. The x-axis value should be in the sequential order. So, whenever you are going with the time series data, for example, time series data you are having like this. On the day 1, the value is 100. On day 2, the value is 105. On day 3, the value is 92. On day 4, the value is 98. On day 5, the value is 110. Something you are having like this. On the day 1, 100. Let us start 100 like this. From next 105. Okay. From 105 to, it has came to 102. Okay. 102 means between 105 and, okay, 102. From 102, it has came to 98. 98. From here again, it went to 110. If it is in the sequential order, you will get a proper graph like this. Now, from this graph, we can analyze easily. Okay, this is the minimum value, this is the maximum value, it is moving in this way. For example, the graph is like this. You have got a graph like this. What you are going to understand, you know, this is in the uptrend. Means it is, though the value is falling in between also, slowly it is increasing in one. It is always increasing. In between it has fall. Multiple times it has fall. Slight, it is not increasing continuously. Though it is falling also, it is in the uptrend. For example, the graph is like this. As the time increases, as the time changes, you are having like this. This is in the downtrend. If the graph is like this, sideways, there is no trend for that. This we are going to use during the stock market analysis. As the time changes, how the share price changes. Individual share price, how it is changing. And based on that, we are going to apply. Right? So time series, for time series data, we are going with the line plot. And for any other data also, you can go with the line plot. There is no problem. But if you are getting the line plot in this zigzag way, you can't analyze anything. So that is the reason the x-axis, whatever you are considering on the x-axis, it should be in the sequential order. Then only a proper plot you can identify. Now, plt dot plot of y. I am going to take only a single variable y. Now, sir, it is a time series data means automatically scatter plot. Na? Scatter plot means two variables should be there, right? If you give one variable, the second variable will be considered as the index values. The second one will be considered as the index. On the x-axis, you are going to take the index values. Is that clear? It is considering the x-axis as the index values by default. If you don't give anything, means by default index values. Clear? If you don't write anything, by default index values. So here I'm going to take df of grade column. Only the grade column I am considering. Now what is there in the x-axis? X-axis index numbers. Just it is going to consider the index numbers. If you give with respect to study hours data. What is the study? Caps lock S and caps lock H. So you are having the study hours data where you are having the index numbers. On the x-axis, it is considering the index numbers. Is that clear? Now, so here you see x is equal to np dot arrange of x. Sorry, arrange of 6. What is the meaning of this? It is going to take from 0 to 5. 0, 1, 2, 3, 4, and 5. Now y is equal to x. What is the meaning of this? This is x. Y is equal to also the same values. That is 0, 1, 2, 3, 4, 5. Z is equal to x square. X to the power of 2. Now z is equal to, for each x value, it is doing the square. That is 0 square, 1, 4, 9, 16, 25. Next, e is equal to x to the power of 3. So e is equal to cube. That is 0 cube 1, 0, 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125. This is the values. Now what you are going to do? PLT dot plot x comma y. What is there in the x-axis? 0, 1, 2, 3, 4, 5. On y-axis? 0, 1, 2, 3, 4, 5. So first 0, comma 0. This is the first data point. 1, comma 1. This is the second data point. Third data point. Fourth data point. Fifth data point. And it is going to add in the sequential order. Whatever the order is there, that is going to add in the sequential order. That is PLT dot plot. You are going to get the values like this. First you have to execute this one. Then you have to execute this one. This is the x values and this is the y values. Is that clear? Now similarly, x comma z. Now what is x comma z? This one to this one. Now first value 0, comma 0. First data point 0, comma 0. That is this one. 1, comma 1. 1, 2, comma 4. This is the 2, comma 4. 3, comma 9. 4, comma 16. 5, comma 25. So you are going to get a curve like this. So the same thing it is going to draw. You are going to get a curve like this. This is 0, comma 0, 1, comma 1, 2, comma 4, 3. This is the each data point. This is the first one, second one, third one, fourth one, fifth one, and sixth one. Right? If you want to see your marker also clearly, in this, you write the size is equal to some 30. Marker size. So just in this, that is option is available. Okay, we have to write the marker size word. This is the keyword we have to use. Okay, we'll use the same keyword. Marker size is equal to 30. So you can see your markers also. So whatever the marker is there, that it is going to add. So for example, if I am adding the marker size more, first I have to start the marker. Marker is equal to, I'm going to take some kind of star. So you can see the markers also. Each marker. First marker will be added, and for that everything will be added in the sequential order. right? So if you want, you can add the markers also. Is that clear? So first it is adding the markers, and after adding the markers, it is adding in the sequential order. Each point to point, it is adding in the sequential order, right? Similarly, x comma e. What is x comma e? X is nothing but 0, 1, 2, 3, 4, 5. E is nothing but 0, 1, 8, 27, 64, 125. So here the number of x values and number of this one both should be equal. If one of them is with respect to like this and second one is not having that one, 0, 0, 1, 1, 2, 8, 3, 27, 4, 64. For 125, what is the number? How it can plot that scatter plot first? Without scatter plot, how we can make the line plot? So it is going to throw an error if the number of values are not equal, miss. And you are going to have like this, right? Now, if you add everything in a single cell, that is plt dot plot of x comma y, whatever I have done here, plt dot x comma y, x comma z, plt dot x comma e, whatever the three values are there, these three of them, I am going to add in a single cell. This I have taken in a separate one, this I have taken in a separate, and this I have taken in a separate cell. I am executing in a single cell. Now everything will be on the single one. So for everything, the x-axis common value is there, na? So for the same x-axis, it is going to add this one. Now out of this, which one is the straight line? Which is x comma y, which is x comma z, and which is x comma e? Now here, this since it is a simple data, and that too you have seen the previous this one, you are able to identify. But in real life, we are not able to identify. So for that, what we are going to do is, we are going to add the labels. Label is equal to linear, label is equal to quadratic, label is equal to cubic. And you are adding the labels like this. Now, after adding the label, we are going to take plt dot legend. Legend means it is going to display the labels. So now blue color line is a linear line which is between x comma y. Now blue line is x comma y, orange line is x comma z, green line is x comma e. Okay, so this in this way we are adding the labels and the legend. If you add only legend, if you remove the label, if you remove the labels, without the label, if you add only the legend also, there is no use. First you have to give the name of the for each of them. Without name, how it can add the legend? So first you have to give the labels for each one, separate label you have to give, and for that you have to add the legend. Now whenever you have added the legend, automatically this is the box, this is the legend. This box, whatever the box is there, this is the legend. Now from this box we can clearly see that blue line indicates linear. Linear is nothing but x comma y. So for example, for your understanding, easy way, what I am going to do is, I am writing here x and y. I am giving the label name also x and y. And this label name as x comma z. X and z. And this label name as x and e. Label name is x and e. So I am going to get the same labels. Whatever the label name you have created, it is going to show the same label name. Now clearly you can understand the blue color is for x comma y, orange color is for x comma z, and green color is for x comma e. Right? So now when we are going to use this kind of thing, this is the question. So application is this one down. So for example, days, you are having Monday, Tuesday, Wednesday, Thursday, Friday, like this you are having. On x-axis, you are having the 1, 2, 3, 4, 5, 6, 7. For each day, this is the maximum temperature, minimum temperature, and average temperature. And you want to compare between on each day, what is the minimum and what is the maximum. Now you are having for each day the minimum temperature, average temperature, and the maximum temperatures in a single plot. Right? So on the day 1, that is on November 1st, this is the temperature was recorded, minimum temperature. On the November 1st, this is the maximum temperature was recorded. On the November 1st, this is the average temperature. From November 1st to November 2nd, whether the temperature has increased or decreased means high temperature, average temperature has increased. At the same time, high temperature also increased, temperature also increased. And slowly on the 5th, November 5th, the temperature has fallen suddenly. And we have seen with respect to the minimum temperature in the November month on the November 5th. Example, Now here it is not number. It is not the exact values. Example I am saying. So like this, we are going to compare. In real life, when we are going to do the work is with respect to for each day, if it is common. So we are going to compare like this. So at that comparison, we are going to bring everything in the single cell. If you bring everything in the single cell, if you execute miss, everything will be on the single graph. If you take separate miss, separate graphs you are going to get. Is that clear, guys? The next one is called as, this is up to here, whatever we have discussed is, first one we have seen the histogram. Second one we have seen the box plot. These both are applicable for continuous data only, not for discrete data. These both comes under continuous univariate plots. This both comes under continuous univariate plots. And next one we have discussed is scatter plot. And after that, we have discussed about the line plot. These both are also applicable for the continuous data. For continuous data, this is bivariate plots. These both comes under for continuous data bivariate plots within the continuous data. And we are having with respect to time series plot also. Time series plot is with respect to line plot, automatically line plot. For time series, only one and only plot is there called as line plot. There is no other option for that. On x-axis, you have to take the time. On the y-axis, you have to take the respective value. What are the values there? And multivariate plots cannot be done on the matplotlib. That is the reason we are going with the advanced library called as Seaborn. Multivariate plots cannot be done on the matplotlib. Right? Now, next one is continuous variable is completed. Now we are moving on to the discrete variable. For discrete univariate plot, within the discrete univariate plot, we are having one is called as pie plot, second one is called as bar plot. This both comes under univariate plots of discrete variable. Univariate means you have to consider only single column. You can't consider multiple columns. Now here, see here, pie chart, where education I'm taking BTech, MTech, BSc, MSc, MBA and PhD. Students are 140 students are BTech, 5 students are MTech, BSc are 30 students, MSc are 8 students and MBA are 12 students and PhD of 5 students are there. Total of 200 students are there. In my batch, total 200 students are there, out of which 140 students are BTech, 5 students are MTech, 30 students are from BSc background, 8 students are from MSc background, 12 students are from MBA and 5 students are from PhD background. Okay, total 200 students are there. Now these 200 students, what I'm going to do is I'm going to create a pie plot like this. Pie plot is going to have total 360 degrees circle, out of which 140 for BTech you have to take. 140 means 140 divided by 200. 200 means 70%. You have to consider 70%. 70% means, for example, I'm starting my plot from here. 70% of 360 degrees. 70% of 360 degrees will be there, right? That percentage you have to draw a graph. So first it is going to calculate the 360 into 0.7. 360 into 0.7. 252 degrees. So up to 252 degrees, it is going to take this one as BTech. Now, next one is called as 5. 5 out of 200. 5 out of 200 is nothing but 0.05%. So whatever it is. So first calculate the percentage. That is 5 divided by 200. 0.025 into 360. 9 degrees. So you are going to draw from here 9 degrees you are going to take for this one 5. After that you are going to take this one. This is 252 degrees. This is 9 degrees. Next 30. 30 divided by 200 which is 15 degrees. 15 degrees you are going to draw. Next 8 divided by 200. Next 12 divided by 200. Next 5 divided by 200. For each of them, you are drawing the degrees and finally you are going to make a pie plot like this. And you are going to get a plot. right? So this is the starting point, and it is going to take in anti-clockwise direction. If you want in anti-clock means anti-clock, or with respect to clockwise means clockwise. You can write as per your choice, and by default it is going to consider anti-clockwise direction. Here this is considering the number of students. Number of how this circle was drawn means based on the values. Number of students. So it is going to consider this one. For each of them, this is the label. It is adding the label for that. Now, how much percentage of students of BTech are there? Miss auto PCT miss percentage. It is calculating the percentage. 70% are from BTech. Radius of 1.5 miss circle radius is 1.5. And here exploit of 0.1 miss the first one will be exploit. If you don't write this exploit, then everything will be attached. Exploit miss. Now out of this one, you want to highlight more number of students are from BTech background. You want to highlight that one. You want to highlight miss, you have to separate that one. How you can separate miss? By using the exploit. Exploit of 0.1. If you write for the BTech, that particular part will be exploit miss separated. Sir, I want to separate the PhD students, sir. I want to separate PhD. PhD in which portion is there? 1, 2, 3, 4, 5, sixth portion. For the sixth portion, you have to do the exploit. Then PhD will be exploit. This particular part will be exploit. Sir, I want to increase the exploit. For example, I'm writing up to 0.5. Okay. If you write with respect to 1, exploit of 1 is more. The exploit is nothing but distance. How much distance it has to be separated. Exploit is nothing but which portion you want to exploit, that one. Sir, I want to exploit with respect to this BTech people, that is this BTech, and along with that BSc also. BSc and BTech I want to add. So BSc also I want to exploit. So BSc also you are exploiting. So BTech and BSc will be exploit. So BTech is exploit and BSc also exploit. Sir, which one we have to exploit? Which one we have to not exploit? Miss, for example, in your class, more number of people are from which background? Or which number of people are with respect to less background? That which either if whichever you want to focus, that one you are going to exploit. Whichever you want to focus, that you are going to exploit. So here the exploit is with respect to whichever you want interested. So if you don't write this exploit, don't write. If you're not interested means no need to write. No need to write the circle, no need to write this one, nothing you no need to write. These are the only 2 arguments compulsory. If you write these 2 arguments, you are going to get like this. Only these are the 2 compulsory arguments. If you don't write this one also, if you don't write the labels also, it is going to make the pie chart like this. For the first one, it is going to make based on the students. For which one it has to create the pie chart, that you have to give now. Without writing this one also, how it will make the pie chart? Minimum is this one. If you write this number of students, miss, first it will start the creating the pie chart. For each one, what is that one? What is this BTech? The labels you have to add, miss, add the labels. Add the labels. What are the labels you want? You add the labels. Labels is equal to education. So labels will be added for that. Next, if you want to represent the percentages also, you use the auto PCT. By using the auto PCT, you will get the percentage. Now percentage will be represented. Now, if you want to increase the radius of the circle, miss, increase the radius of the circle. That is as per your interest. It is not mandatory. If you're not interested, miss, don't add. And similarly, exploit, if you want to add, miss, add the exploit. Remaining everything are additional parameters only. Compulsory is this one. Only the first one is the compulsory. Is that clear? Just I have added first one, for that second one, for that third one, slowly I am adding one by one and I am showing you. Is that clear, guys? So which part should be exploit, miss? Which part you want to highlight, that one you have to exploit. Done? Next one is bar plot. Now the same thing you want to represent on the bar plot. Whatever the above data is there, that is 145, 38, 12, 20, 145, 175, 195, 200. Okay. So 140, 140, 145, 30, 8, 12, and 5. The same data, number of students and education, the same data. Now I want the students on the y-axis. The number of students I want on the y-axis at the bar of the height of 140 and a bar of 5. The height of 5 I want with respect to MTech. The name I want to keep here MTech. So you are going to take TLT dot bar. TLT dot bar on x-axis what you want? Education on the x-axis. On y-axis what you want? Number of students. So you are going to take like this. Now what is the difference between above and below? Above one, the pie chart, and below this one is bar chart. Both are indicating the same. This generally will represent whenever there is a percentages. When there is a percentages, we'll go with the pie chart. This is visual representation. In the entire data, how much percentage of these people are there, how much these are there, like that. Is that clear? Now this is with respect to bar chart. Now, if you want horizontal bar chart, the same thing you want in the horizontal way. So bar H, just apply the bar H. So you'll get the horizontal bar chart. This is the vertical bar. This is the horizontal bar. Right? Now, next one is called as stacked bar. The next type of bar is called as stacked bar. Stacked bar means, see here, company is the Google, Amazon, Microsoft, and Facebook. I'm having 4 companies, and these are their revenues, and this is their profits. Now, what I'm doing is TLT dot bar, TLT dot bar, TLT dot bar, company on the x-axis. What is there in the company? Google, Amazon, Microsoft, and FB. That is Facebook. You are going to get like this. And revenue means 90. So up to 90, it is going to make a bar, height of 90. Next one is Amazon, up to 136. It is going to make up to height of 136. This is 90. Now after that, it is going to take 89. 89 means up to this one. This is 89. After that, 27. FB of 27. This is the first bar. Second bar, below this, I am having immediately TLT dot bar. Same company, once again same company. For Google, now this time 40 only. So what it is going to do? First it has created a bar like this. The first bar is like this. This is the first bar. Okay, first it has created the bars like this. Okay, after that, now for the same company, profit of 40. So now it is adding up to 40 here. Again, one more bar. Over this, it is going to draw one more bar like this. So first bar is up to 90, second bar is up to 40. Second one, again 20. So height of 20. It is going to make a height of 20. And 34. Height of wherever the height of 34 is there, this is the 34. And 12. 12 means wherever the 12 is there, this is the 12. So you are combining 2 bars in a single one is called as stacked bar. Then it is called as stacked bar. Okay. Now there is an interesting question. So here revenue of 90 is there. Instead of here 40, if I take 100. Now first bar for the Google up to 91 bar, blue color bar was drawn. 100 orange bar was drawn. 100 means up to here. Now if I execute, 100 only displaying. Where is 90? 90 is back side. Already drawn, but it is back side covered. You have drawn the blue color like this. And over this, you have drawn the pink color completely, have closed. Sir, I have not drawn the blue color, miss. Whether you have drawn or not drawn. In the back end, the blue is there, but it has been covered off. So here, whatever the value is there, this value 90, it is 100. First blue color up to 90 was drawn. 100 orange color was drawn over the blue color. So that is the reason you are not able to see the blue one. Now, if you write here only 10 miss, now you can easily see 90 blue color, 10 up to orange color. Is that clear? So for the same company, if you are having with respect to profit and revenue and you want to compare, then we are going to use the stacked bar. Sir, for example, let us take some value, sir, where this value is over this one. It is crossing the over that one. Stacked bar means it is covering off. I don't want to like that. I want side by side, sir. Means blue color like this, orange color. immediately blue color, orange color, blue color, orange color, blue color, orange color. I want side by side. I don't want combine of like that. I want side by side, means you have to write the code with this one. Then you are going to see side by side. Now, how you can write this code, miss? How you can write this code, miss? First, the same company, the same revenue, the same profit. Everything is same. Whatever is the above example is there, the same thing I am considering. I am not changing the above example. Input is same. Now, what I am considering is, first, this is the data point. Okay. For this data point, what I am going to do is, I am going to give the np.arrange of up to 4. That is 0, 1, 2, 3. So on the graph sheet, you are going to take this one as 0, this one as 1, this one as 2, this one as 3. Now what you are going to do, first bar where you have to start, means from minus 0.2, means from this I am going to move to the left side, minus 0.2. From here you have to start the bar. Where you have to end with the thickness of 0.4, means up to plus 0.2 you have to take. This is blue color. The blue color will start from minus 2 to plus 0.2. The next orange color is there, na? That will start from 0.2 to the next value will start from 0.2 to 0.6 up to 0.6. I have given a thickness of 0.4. Just observe this one. So np dot arrange of length of the company. Length of the company means what is meant by length of the company? Length of the company is 4. np dot arrange of 4 means 0, 1, 2, 3. Now expose minus 0.2. What is meant by 0.2? For this value, it is going to do the minus 0.2. That is minus 0.2. For this number, minus 0.2. That is minus 0.8. For this number, 1.8. For this number, 2.8. Here you have to start the revenue. Revenue means 90. From here you have to start a revenue of 90 and width of 0.4. Where you have to end means up to 0 with thickness of 0.4. So thickness of 0.4 means 0.2 you are going to get. Is that clear? So this is the starting point. Once again I am explaining. This is with respect to minus 0.2. This is plus 0.2. This is plus 0.6. This is 1, out of which 0.8 it has started and it has ended at 1.2 and with 1.6. So with a thickness of 0.4 I am giving. What is the starting point I am taking is starting point of minus 0.2 is the starting point. And thickness of 0.4. Width. Height will be decided based on the value. Value 90 is there, na? That is the height. Thickness. I am giving only the thickness of the bar. So in this way, I am going to get the bar side by side. This is called as stacked bar. This is called as unstacked bar. Unstack. This is stack. Stack means combined. 2 bars attached to each other. 2 bars are side by side each other. Got the point? Is that clear? So see here. That is with respect to. Now, and explain once again, sir. If the second bar is more than, Bhupendra, is your question is clear? I think already I have solved your question. If the second bar is high, value is high, means automatically it is going to cover, right? Now, here in the auto percentage, if you go with the auto percentage, 1.1f, what is this 1.1f? Means this is a syntax up to 1 decimal. This is the syntax for 1 decimal. To go for 1 decimal, this is the syntax. 1.1 f float value up to 1 decimal. You are considering up to 1 decimal. That is the syntax, right? Now, once again, I am explaining this one since side by side. So once again, first line, first you take the first line, company, it is a list, revenue, it is a list, third line, profit, it is a list. You know all these things. These 3 are core Python, common. Na? Now, expose is equal to np.arrange of this one. Arrange of that one means it is going to have an array of 0.0, 1, 2, 3. So now just I am printing this expose separately. Print expose 0, 1, 2, 3. Is that okay? Now expose minus 0.2. I am doing. Now what happens? Every value will be minus 0.2. Now this is the starting point. Minus 0.2 minus 0.2 0.8, 1.8, 2.8. This is the starting points for the bar with a thickness of 0.4 from minus 0.2 with plus 0.4. From where it is going to end? Obviously, it has to end at 0.2 only. Na? 0.8 it has started, miss. Where it has to end? 1.2. It will end at 1.2. 1.8 it has started, miss. 2.2. 2.8 it has started, miss. 3.2 it will end. Like this, I am going to make the first bar. First 4 bars I have made. Second 4 bars, what I am going to do is expose plus 0.2. What is expose plus 0.2? 0.2. Here it is starting. The second bar is starting in this location. Here the second bar is starting and thickness of 0.4 means up to 0.6. 1.2 to 1.6. 2.2 to 2.6. 3.2 to 3.6. Is that clear? Thickness. What is the thickness you are giving? Is that clear now? Any questions? Now from this bar, what you are analyzing is Amazon is having revenue wise very high, profit wise it is having very low. Revenue wise Amazon is high, profit wise Google is the high. That comparison, for comparing that one, we are doing this bar chart. For example, sir, you can take separately also. Na? For example, why you have to take everything in the single? Let us try in this way. I'm copying. Okay, I'm pasting here. And I'm going to consider only one bar, not the second bar. Since one bar means no need of this one also, nothing is required. This is not required. This is not required. Everything is not required. Next, just you required with respect to on the x-axis, what you want is company. Okay, company you want on the x-axis, revenue on the y-axis, and label was not required. Nothing is required. Nothing. And I'm writing plt.show. Now, if you see this one, here you have got with respect to Google, Amazon, and Microsoft and Facebook, and the heights of each one. This is a normal bar chart. It's normal bar chart. Similarly, you are going with respect to this one also. Similarly, one more chart. This time, instead of writing the on the y-axis revenue, I'm taking the profit. Okay. Instead of writing in the revenue position, I'm writing the profit in this position. Profit. Now, if I execute, I'm getting the bar chart like this. This is separate bar. This is separate bar. From this, we can clearly say that Amazon is having the highest revenue and Google is having the highest profit. This we can say from this one directly. But the thing is that if you want to compare side by side, you want to do the side by side comparison. At the time, what you are going to do is this is unstacked bar. Either by applying the stacked bar or unstacked bar, you are going to do the comparative analysis. Is that clear, guys? And we are having called as tight subplots. We are having next concept called as subplot. Okay. So let me clear off this from here to here. So here I'm having e-commerce, that is Snapdeal, Alibaba, and Amazon and Flipkart. These are the 4 e-commerce websites, and Q1 profits, Q2 profits, Q3 profits, Q4 profits for 4 companies. If I want to bring side by side, I know what is unstacked bar. Instead of unstacked bar, I can even use the subplot. Subplots means plt dot subplot. You are using plt dot subplot 2, 2. What is meant by plt dot subplot of 2, 2 means 2 rows, 2 columns. It is going to create 4 plots like this. Plot 1, plot 2, plot 3, and plot 4. 4 plots you are going to get. Out of 4 plots, in the first subplot, what you want to keep is bar with respect to e-commerce versus Q1 profit. E-commerce, that is Snapdeal, Alibaba, Amazon, and Flipkart, and their bars. What are the bars are there? In the subplot 2, this is subplot 2. In the subplot 3, in the subplot 4, what you want to have in the subplot. So now we are going to get from each subplot like this. You can get for each subplot. Now, sir, here everything are concatenated, side by side. We can't see Alina. So you can increase the figure size. You can go with the figure size. I'm going to write the figure size, this one. PLT dot figure size of 10 by 10 means I'm going to increase the figure size to 10 by 10, big size. Is that clear? Figure size, just you are increasing the figure size. Figure size is nothing but earlier in this location only you have drawn the graph. Now you are drawing in this location, increasing the space, figure size. Sir, here you have taken with respect to 2 comma 2 comma 1, sir. Okay. 2 comma 2 comma 2. Okay. 2 comma 2 comma 3. 2 comma 2 comma 4. So 2 comma 2 means total 4 plots. 2 by 2. This is the 4 plots, out of which this is the first one. This is the second one. This is the third one. And this is the fourth one. Sir, for example, I have written the 3 by 2. What is meant by 3 by 2? 3 rows, 2 columns. Total 6 plots you are going to get. 3 rows and 2 columns. This is plot number 1, plot number 2, plot number 3, plot number 4, plot number 5, plot number 6. 1, 2, 3, 4, 5, 6. Now you have written 3 comma 2 comma 1. Means first plot you want this one. In the second plot you want this. In the third plot you want this. In the fourth plot you want this. Now if you print means you are going to get with respect to like this. Whereas fifth and sixth is you have not written anything now. Now what I am going to do is this I am going to keep in the fifth position instead of fourth one, fifth one. Now what is there in the fourth one? Empty. Nothing is there. In the sixth one? Empty. So now I am going to get in that positions empty values. In the fourth one and sixth one empty. For example, this one you are considering the sixth position. 4 and 5 will be empty. So this 4 and 5 will be empty. Is that clear? This is subplots. In the subplots, you may take bar chart, you may take line plot, anything. Each one is a separate plot only. There is no connection between each of them. You can separate this. There is no connection between these two plots. In this, you can write the line plot. In this case, you can take the histogram. In this, you can draw the box plot. As per your choice. Each one is separate. Now, everything you are going to get in a single by comparison side by side. To get everything in a single one, we are going to create the subplots. Clear, guys? So that is the matplotlib. In the matplotlib, we have seen with respect to histogram, box plot, scatter plot, line plot, bar plot, and pie plot. These are the basic plots. And in tomorrow's class, we are going to see the Seaborn with advanced visualization. Once Seaborn also completed, with that, the prerequisites of data science will be completed. From Monday, advanced level, we'll go to the next level. Prerequisites will be completed. Actual data science will start from Monday. Right? Yeah, sir, please show how to increase the size. Size is nothing but PLT dot figure. Figure size is equal to 10 comma 10, or you can write with respect to 100 comma 100 also. You'll get a big size. A very big size. So you can take as per your choice, whatever the size you want. Right? Done?